Okay, so the last thing I'm going to cover in this particular unit, and I know I've covered a lot of materials already because this is a very heavy unit in terms of the materials that are covered. Practice, practice, practice. The last thing I'm going to discuss here, and this is something that I will actually like to teach with the ionic materials, is naming of these covalent compounds. And we're going to finish up the naming of compounds. So remember, we've used these when we're dealing with stuff that is just non-metals. So remember that nomenclature rules are always based off of what the molecule starts with. In this case, if it starts with non-metal, you're going to follow this set of rules. And it's very easy because we're not dealing with charges. We're not dealing with Roman numerals or anything like that. There's no crossing and dropping. We just focus on prefixes, and those prefixes are based off of the number of atoms that are present. So the best way to do this is to look at kind of the generalized formula for this. It is prefix plus the full name, and then prefix plus the second stem "ide." There's no charges, no cross and drop, and we actually omit the prefix mono on the first name. And if you look at the prefixes on the right-hand side here, you should be familiar with most of them if you've taken any basic geometry class in high school. Mono is 1, di is 2, tri is 3. Tetra is the tricky one because many people want to put quad there, but tetra means 4. And the easiest way to remember this is if you've ever played the game Tetris, which is a very old school game, but I am an old school individual, that the individual, they're called tetrominos, the individual little blocks that actually fall down are made up of 4 blocks each. So tetra means 4, penta means 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So we use these prefixes again based off of the number of atoms that are present. So look at the examples on the right-hand side here. CO, carbon monoxide. That goes back to that last rule. We omit mono on the first name if it just has 1. Notice there's no reducing either. O2, F2, dioxygen, difluoride. We don't reduce them here. So if we're dealing with something that is, I refer to this as type 3, or something that is covalently bonded, we only focus on the prefixes. We do not reduce any of these as we work through them. So we have the following compounds. They're containing nitrogen and oxygen. Let's go through and name them. Take a few moments with this and we will name them together here in just a moment, and then we'll be close to being done. So we're going to use prefixes for these. And the reason I know we're going to use prefixes is that all of these start with a non-metal. Okay, so let's look at what we have here and use the prefixes and go from there. So NO, we know that this is going to be some form, well, all these are going to be some form of nitrogen. And it's going to have oxide. We don't use mono for the first prefix here, but we would for the second. So this is nitrogen monoxide. NO2, again, nitrogen. 2 oxygens here. The prefix for 2 is di, so this is nitrogen dioxide. N2, we use prefixes for the first one if it's not mono, so this is dinitrogen monoxide. N2O3, dinitrogen trioxide. N2O4, again, no reduction here. Dinitrogen tetra oxide. Sometimes we drop the O there, it just depends, but as long as you're following these steps, you should be fine. Remember, no mono on the first, mono on the second for sure. So anything with the number of atoms on the second part, you always include the prefix. You include the prefix with the first part. You just don't include mono if it's just 1. Easy way to remember that, it's called carbon dioxide, not monocarbon dioxide. All right? Last one here, we're going to write out the formulas for the following compounds. So we're going to utilize the prefixes we just discussed. We're just going to kind of figure it out using different molecules this time. And you should be able to work forwards and backwards as you do this as well. So we'll practice with some of the opposites here probably in the next video. So write out the formulas for the following compounds. Well, let's do that. So CO, each has a prefix of 1. So this is carbon. Remember, we don't use the mono prefix on the very first one. O is oxide. There's just 1, so this is carbon monoxide. HF, again, 1 atom of each in the molecule, so this is hydrogen monofluoride. Okay, for those of you who are familiar with acid nomenclature, this is going to be written a little bit differently. We don't do acid nomenclature here in 1030. SO2, S is sulfur. O2, dioxide. P4O10, so 4 is tetra. P is phosphorus. We have oxygen here. O is 10, so this is decaoxide. So again, sometimes that O is left off there. Doesn't really matter for me one way or another, as long as you get the prefixes down. So that being said, there's a lot that's going on here. We've covered a lot of material: Lewis structures, covalent bonding, geometry, polarity, and naming of compounds. Again, take this information here, especially for the naming. Make sure you incorporate that with the naming materials we looked at previously, because mixed practice is very, very important. The first thing you should do when you're dealing with mixed nomenclature practice is make sure that you understand how to name things correctly. Make sure that you know what the chemical compound is starting with. That tells you what rules you use. These rules with the prefixes, you're only doing prefixes if it starts with a non-metal. That is, it starts with something that is to the right of the stair step on the periodic table or hydrogen. Everything else, charges and cross and drop. So that being said, that is a brief overview of all the material here in chapter number 5. I know it's a lot. We're going to kind of skip ahead and move forward to, I believe, chapter number 7/9 is the next one we're going to look at. I'll have to remember off the top of my head. I honestly don't remember. But if you've liked the video, if you thought this was helpful, leave a like, subscribe if you're interested in more chemistry content. Thank you so much for watching. If you have any questions, feel free to reach out. I'll be happy to help you in any way, shape, or form. Have a fantastic day, and we'll see you soon on the next video. Bye, everybody.